Hi there. In this video we are going to look at another question regarding the efficiency, and in this case the input energy is natural gas. A combined heating and hot water boiler bears 0.30 cubic meters of natural gas in 10 minutes. During those 10 minutes, 28 liters of water are heated from 15 degrees Celsius to 85 degrees Celsius. Calculate the amount of heat released by the combustion of the natural gas. But before we get to the questions, first I want to draw the diagram of this question here. So here we have a boiler. The input energy is gas. The output energy is heat as useful, and so Q is the useful energy. And we also have some energy loss, and as I said, it could be also as heat. So this is energy loss. So first I'm going to calculate the input energy. So here, how can I calculate the input energy? The energy that actually can be released from burning natural gas. So if you read the textbook carefully, it says that a cubic meter of natural gas release 32 megajoules energy, and in this case we are burning 0.30 cubic meters. So E is 0.30 times 32 megajoules, and that is 9.6 megajoules, and mega is 10 to the power of 6. And what about part B? Part B says that calculate the amount of heat taken up by the water that has been heated. So that Q, we are going to calculate heat, and heat is mass times C times delta T. And if you remember, the specific heat capacity of water is 4.2 joules per gram degree Celsius. And then we have delta T, the temperature difference, which is 85 minus 15, that gives us 70 degrees Celsius. What else do we have? We also have mass. Mass is 28 liters, which is 28 kilogram, which is 28,000 gram, and I converted it to gram because here we have joule per gram. And the reason that 28 liters is 28 kilogram is because the density of water is 1 kilogram per cubic meters. So if I multiply them together, I can get Q. So Q is 28,000 times temperature times the specific heat capacity is this. So I can write it down as a power of 10. So it's 8.2. So this is 8.2 times 10 to the power of 6, which is 8.2 megajoules. And then I'm going to calculate the efficiency. So the efficiency is Let me use a brush now. Efficiency is the useful energy divided by the total energy times 100. So useful energy is 8.2 megajoules, and this is 9.6 megajoules times 100. So mega is 10 to the power of 6. So we have 10 to the power of 6 on the top. We have 10 to the power of 6 on the bottom. And these two cancel each other out. So 8.2 divided by 9.6 and then multiply by 100 is the efficiency, 85%. So the efficiency is 85%. That means that 85% of the total energy will be transferred to the useful, and 15% is energy loss. But pay attention to something. So this is a very straightforward question. In the test, we might have something totally different. In the test, for example, you might be given the efficiency and the total energy. So you have eta, you have E, and then the question is, for example, calculate the final temperature. So what do you need to do? In that case, first you need to calculate the useful energy. So the useful energy is efficiency times total energy. Okay, then when you have the total Q here, if you remember, we have this triangle. We have Q, we have mass, we have specific heat capacity, and we have delta T. Even if the question is calculate the final temperature or calculate the initial temperature, first always calculate delta T. So we want to calculate delta T. Put your hand on delta T. So delta T is Q divided by mass times the specific heat capacity. And Q, you need to use the efficiency that you have and the total energy and calculate Q. Then when you have calculated Q, put Q here. Then we have the mass, we have the specific heat capacity. You can calculate delta. And then when you have delta, you know that delta is the final temperature minus the initial one. So delta is let's say 70 degrees Celsius, and you have the final, so you have 70 here, so you have 70 here. We are looking for the final temperature and we have the initial temperature. So something minus 15 is 70, so that means that this is 85 degrees Celsius. So pay attention. In the test, you don't have a easy peasy question like this. You might have a question like that, and this is how you need to handle this.